All right. Shit. Good morning, people. Okay, that is very great start. Yeah, here. Guess I need to get my towel as well. Yeah. So we are here, people. Go to the categories. We were doing the digital logic problem yesterday, if I'm not wrong. Oh, damn it. Yeah. So we were doing this problem. Yeah, I remember this one. Yeah, this one. No, no, we did this one already. Yeah, this is a problem that we are doing. It's good. Yeah. So x is given to us in the IEEE 754 notation, that is 356 double zero triple zero. Y is given to us as 34a double zero triple zero. Z is equal to x plus y. And what is Z in IEEE 754? To be honest, there is nothing much to think about here. It is just a manual thing to do, right? So 3 is double zero double one, 5 is 0101, right? C is 10, B is 11, C is 12, that is 8 4, that is C, and that is it. And similarly y is double zero double one, and 4 is 0100, and A is 10, so that is 8 plus 2, that is 1010, and remaining all we got the zeros. So the value is minus 1 to the power of sine bit into 1 dot mantissa times 2 to the power of exponent. So if you look at the exponent, 1, 2, 3, 4, 5, 6, 7, and 8. This is the exponent, right? That is 1 plus 2 plus 4, 8 plus 1, 2, 4, 8, 16, 32 plus 64. How much is that? 8 plus 2 is 10, 11, 64 plus 32 plus 11, that is 7, 6 plus 3, 9, right, 107. So you are supposed to subtract it from 120, right, 127, that is going to be minus 20, that is the unbiased exponent, and this is mantissa. So the sine bit is going to be 1, right? So 1 point, the mantissa is going to be 1 into 2 to the power of minus 20, that is going to be x value. And similarly y value is 1, 2, 3, 4, 5, 6, 7, and 8. So it is going to be 1 plus 2, 4, 8 plus 16, 32 plus 64, 32 plus 64, right? Plus 9, 64 plus 32 plus 9, that is going to be 9 plus 2, 11, 1 plus 4, 15, 9, 105. So if you subtract 105 plus 1 minus 127, how much is that? God, 22. So that is going to be minus 22. And again, this is going to be the mantissa 0, 1.01 into 2 to the power of minus 22. This is going to be y. So x plus y, you need to make the bases equal. Right. So which one's easier? Um, okay, you need to make the bases smaller. So it will be 1. Okay, now you can add them all together. This is the value of z, and if you like try to plot it out, the it is going to be 0. Hmm. You need this form, right? So if you make this value smaller, you need to make this value bigger. 1.1101 into 2 to the power of minus 20. It is the same. All right. And mantissa is 1101 something, and exponent, right? Minus 20 is a biased exponent, and I guess you need to add 127 to this. 107. Yeah, I guess it is. How many bits of mantissa we got? We got 23 bits of mantissa. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 107 can be represented as, if you do the 53, 1 and 2, that is 26. Yeah, 26 and 1. Yeah, right? Yeah. And 13, that is 0, and 2, 6 are 12, that is going to be 1, and 2, that is 3, that is 0, and 2, that is 1 and 1. So if you take that from the bottom up, you will get 1, 1, 0, 1, 0, double 1, but there is only 7 bits, so you will have a 0 over here. And if you try to convert this thing out, right, what is this? I thought that is the only thing, right? Oh shit. 1.1101 into 2 to the power of 20, converting Z to. Right, we got it. How did this guy get this? Wait, okay. Wait, my bad. You will have sine bit and then you will have the exponent. The value of exponent, that is 107. Here you have 107. Yeah, 00. This is a sine bit. and 0 double 1 0 1 0 double 1. This is the exponent, and there is a mantis. And then you will have double 1 0 1. Remaining, you will have all of this as padding. So this is going to be the 3, and these 4 bits constitute 5. Okay, and this 4 bits, that is 2 plus 4 plus 8, that is 6 plus 8, that is 14. 10A, 11B, 12C, 13D, 14E. How many options do we have? Okay, and now this is 8. So 3, 5, 8, the C is going to be your answer. Okay, it took me a lot of time, obviously, but it is alright. Okay, we did this one. Wow, that question alone took you like 10 minutes. You can't increase your pace. 2-bit saturating up or down counter that performs a saturating up when input phase 0, saturating down when phase 1. The next stage, the counter is built as synchronous sequential circuit using D flip-flops, which are the following options correspond to the expression of the input of D flip-flops, D1 and D0. We have the brother chart GPT for this one. Can you please this question? We were not told digital Okay. So what did this guy do? Since it's a D flip flop, D1 is equal to Q. Did he rewrite the table? Q1. Do you know? Get rows where D1 is equals to 1. Okay. Double 0 1 0 1 0 0 1 1 triple 1. Okay. Okay, everything is built on zeros and ones of our own signals where circuits process inputs and produce outputs. Logic gates and are not core building blocks and output 1 only if all inputs are 1, output 1 if only input is 1, not flips input. Okay, combinational versus sequential circuit output depends only on current input. Example, we have adders, multiplexers and decoders. Okay. Sequential output depends on current input plus past state memory. Example, flip-flops, counters, and registers. What is a flip-flop? A flip-flop is a one-bit memory. It either shows 0 or 1. Okay. So the next state is depend upon the input D. Each flip-flop stores one bit, Q1 or Q0. Input to flip-flop is equal to D. Output after clock is equal to next state. Okay, input decides the next state. What is state table? A state table is behavior of system. It tells current state, input, and next state. P control input. Okay, Q1 is equal to Q1 Q0. Current memory. Okay, it is a 2-bit saturating counter. Means if p is equal to 0, that means it is counting up. It's p is equal to 1, it is counting down, but stops at max on 1. Okay, okay, that honestly makes sense, right? It stops at min. You can see the table. It is counting down. So 0 0, there is no down to 0 0, so it stays as that. And 0 1, wow, the the minus one of 0 1 is 0 0. We got that. And 1 0, it will have 0 1. This is basically 2 and this is 1. And 1 1, this is basically 3, and it counts down to 1 0, that is 2. Okay. Okay, it is counting down in these four cases and it is counting up in these four cases. Makes sense. See, I did not see this, but I have understood. That is thanks to a great teacher like you. Find logical equations for D inputs. What input should I give to flip flop so that they move correctly between states? Combinational logic. Okay. Yeah, honestly, I have understood this. Uh, so- right. I have actually understood what it is trying to say. Let's see. Saturating up, down, counter. P, Q1, Q naught, Q1 plus, Q naught plus. Double 0 0 0 1 1 0 1 1. Again 0 0 0 1 1 0 1 1. So there is the counter up of 0 0 is 0 1, and it is 1 0, it is 1 1, and it is 1 1. Again the counter down of 0 0 is 0 0, 0 1 is 0 0, 1 0 is 0 1, 1 1 is 1 0. I have drawn the table. Wow. So, okay. Counting down, up, 4 possible, possibles, right? Corresponding up values. Corresponding down values. Stops up count at 1 1. Stops down count at 0 0. Hope that makes a lot of sense. Now we are supposed to make a transition table. D1 is basically Q1 plus. D0 is basically Q0 plus. Okay, so D1 is equal to Q1 plus is equal to 1 at 0001 010 011 111. And what are you going to do with these values now? Okay, so that is going to be P bar Q1 bar Q0 plus P bar Q1 Q0 bar plus P bar Q1 Q0 plus PQ1 Q0, right? And now you are supposed to simplify this one. Simplify it. How are you going to simplify it? Do we have any common terms over here? The first intuition that I will get is if you take P bar common here, Q1 bar Q0 plus Q1 Q0 bar plus Q1 Q0 plus PQ1 Q0. And can we derive anything meaningful from this? Q0 you can take it common. Q1 bar plus Q1 plus Q1 Q0 bar plus PQ1 Q0. How do you simplify this? Q1 bar plus Q0 is 1 all the time. So P bar Q0 plus Q1 Q0 bar plus PQ1 Q0. Do we have any? Alright. How do you simplify Boolean expressions? Yeah, I don't care how many questions I complete. I just need. Oh my god, my hand is paining. One of the highest ROI topics in digital logic if you master Boolean simplification. Reduce logic expression into simpler terms, thus get faster throughput. So here you take A common, B plus B bar is equals to 1. Okay. Let's do this one. Warm up. A B bar plus A B can be transformed to if you take A common, B plus B bar, that is A into 1, that is A. Okay. So A plus 0 is equals to A times 1 is equals to A. Right. A plus 1 is equals to 1, A times 0 is equals to 0. That makes sense, idempotent. A plus A is equals to A times A is equals to A. Right. A plus A complement is equals to 1, A times A complement is equals to 0. A plus B is equals to B plus A B is equals to B A. All of that makes sense. A plus B plus C is equals to A plus B plus C. Okay, associative law. A into B plus C is equals to AB plus AC. That is distributive law. Okay. You have absorption. Everybody knows this. Maybe the blue and blue is like camouflaging a lot. Yeah, it is honestly much more better. A plus AB is equals to A into A plus B is equals to A. Okay. Independent of B. That makes a lot of sense. So if you have something like P dash Q1 plus P dash Q naught, then you can P dash Q1 plus Q naught. Okay. And similarly P dash Q1 Q naught dash plus P dash Q1 Q naught You can like P dash Q1 and Q naught plus Q naught bar. That is it. Okay. So we are studying a lot for this one question, but it is alright. So you got the expressions, or maybe you can draw three variable K map to get these things right. These ones. Okay. Well, let's write this again. So this is P dash Q1 dash Q naught plus P dash Q1 Q naught dash plus P dash Q1 Q naught plus P Q1 Q naught. These are the four expressions that we want for the D1, right? So you can draw something like this actually. Yeah, we got P Q1 and Q naught, P dash and P, Q1 Q naught dash, Q1 dash Q naught, Q1 Q naught. That's it, right? 0, 1, 2, 3, 4, 5, 6, and 7. So P bar Q bar Q naught, that is here. P bar Q1, that is here. Q1 Q naught, Q1 Q naught, that is here. P Q1 Q naught, here, that is. So how can you group these together? These two, and these two. Like this, and again like this, and again like this, right? So that will be P bar. Honestly, this is even slower, man. Q Q dash, right? Q naught plus P dash here. What cancels out? Again Q1, and here Q1 Q naught. We got any one of those satisfying? P dash Q naught. Okay, P dash Q naught. Okay, we got four. P dash Q1. Okay, Q1 Q naught. This is the only thing. So B is your answer. Wow, wow. Okay, we solved it finally. That we got right. That is basically SOP. Just draw four variable K map, and we are supposed to finish this thing off easily. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now we got one, we got two, wait, we got two, we got three, we got four, we got five, we got seven, we got um, we got 10. Right. Yeah. What am I even thinking? 7, and then you got 10, you got 12, you got 13, you got 14. Let's erase this thing. How many groups am I seeing? You can see these. This is forming as a group, and this is okay. 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 That honestly makes a lot of sense. P Q R S. P dash Q dash P dash Q P Q P Q dash R dash S dash R dash S R S R S dash. That's it. Now you will just do this, right? So from these two groupings you will get Q, and from these two groupings you will get R dash plus, and Q dash is going to cancel out P dash, and here R dash is going to cancel out S, and from here RS dash SS dash is going to cancel out R, P Q dash P dash Q dash R, and Q dash P R S dash. That is it. P bar S. Okay, we got P bar S, and Q R bar. We got it in both of them. P bar Q bar R. We got this one in A and B options. P R S bar. So B is going to be our answer. D as well. Okay. It is MSQ. You won't get any marks for all this. P dash SQ bar. Come on, man. How are you even going to know what to do? So one question is actually enough to get all of your energy down. Anyways, what was this one? Come on. Function is one for these min terms. Okay, nice, nice. So, um, so B option matched, and let's see why did not C option matched, right? P bar. Okay, where did you get like P bar? Okay, P bar S is present, and Q R dash Q R bar is also present. P Q S bar P Q. mm, how did he group to get PQS bar? That means RR bar needs to cancel. RR bar needs to cancel. So these two rows and PQ. These two, right? Yeah. P bar, Q bar, S, we will get that. But how will you get PQS bar? The second way is more correct, to be honest. P bar S, that means PQ RS. P bar means 0 and S means 1. There are four combinations, that is these, that is 1 and that is 3 and that is 5 and that is 7. Okay, these are the main terms that it is covering. So easy elimination. So if you see P bar S is present in all the four options, so no need to check for it. Q R bar is present in all the four options, so no need to check for it. P bar Q bar R, is it present? And P Q S bar, is it present? P R S bar, is it present? Q bar R S bar, is it present? P R S bar, already written that, right? Are these four things present here? So that is 0, 0. R is going to be 1. So it can either do it 0 or it can do it. So 2 comma 3 are both of those present. Yes. So P bar Q bar R is present. P bar Q bar R is present. And P Q S bar. So P Q S bar. So this one and this one. So that is 8, 4, 12, 13. 8 4 is 12, 12 plus 2 is 14, sorry. And 8 plus 4 is 12. Are both these present? 14 and 12, both of these are present. So P, Q, S bar is also present. P, Q, S bar. P, R, S bar. That means P, R, S bar. P, R, S bar. So that is 8 plus 2, 10. And that is 8 plus 4, 12 plus 2, 14. Is 10 present there? Yeah, it is also present, man. Q, R, S, bar. Oh god. Sorry. So P. So this is what? This is 0, 1, 0. And you can either do this, right? 8 plus 2 is 10. Everything is coming. Okay. It needs to cover everything. Okay. That makes a lot of sense. Wow. So you have these things fixed, p, p, r, and s. So that is going to be 0, and that is going to be 1, 0, 0, 0, 1, 1, 0, 1, 1. So that is 1, that is 3, that is 5, and that is 7. And q, r bar, p, and s. This is 1, and this is 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 1. So this is covering 4, this is covering 5, this is covering 8 plus 4, 12, and that is covering 13, right? Okay. P bar, Q bar, R. P bar, Q bar, R, S. So 0, 0, 1, and it can either cover 0 or 1. 1, 0, 0. So this can be either 2, and this can be also 3. And Q bar, R, S bar, T. 0, 1, 0, 0, 1, 0, and it can be 0 or 1. So that is 2, that is 8 plus 2, that is 10, right? So the covering is 1, 2, 3. Do we have a 4? Yes, we do have a 4. And do we have a 5? Yes, we do have a 5. 7, yes, we have it. And 10, yes, we have it. 12, yes, we have it. 13, yes, we have it. 14, no. So you have P bar S, P bar S, QR bar, P bar Q bar R, Q bar R S bar. So P bar S is going to be 1357, and Q bar R is going to be 4, 5, 12, 13. Okay. And P bar Q bar R is going to be 213. Both of them are present. And P R S bar, P R S bar Q, 1, 1, 0, 1, 1, 0, and it can be 0 or 1. So that is 8 plus 2, that is 10, and 8 plus 4, 12, 12 plus that is 14, 10 and 14. So 1, 2, 3, 4, 5, 7, 10, 12, 13, 14. Yes, it is covering. And P bar S is going to be 1357. Q bar R is going to be 4, 5, 12, 13. PQ, PQS bar, PRS bar, PQ. Okay, you have PQS bar already. 10, comma 14. Oh, no, 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 no. Sorry. You have PQ. Alright, so 110, 110. It can be 0 or 1. So that is 8 plus 4, 12, and that is 8 plus 4, 12, comma 14. You have another 12, comma 14. PQS bar and PRS bar. You have a PRS bar already. That is another 10, comma 14. So 1, 1, okay. It did not cover 2, did it? No covering for 2. 1, 3, 5, 7, 4, 5, 12, 13. P, PQS bar. PQS bar. That is another 12, 14. Q bar or S bar. Q bar or S bar. 0, 1, 0, 0, 1, 0, 0, 1. That is going to be 2. 8 plus 2, 10. It covered 2 and 10 as well. So you have 1, you have 2, you have 3, you have 4, you have 5, you have 7, you have 10, you have 12, you have 13, you have 14. Yep. B and D. How much time did it took? Yeah, it took a lot of time. We are not going to talk about it, but we have understood what he is trying to do. Oh God. We already did this one, right? Saturating. Yeah, if I'm not wrong. We did this one just now. And we did this one as well. We did this one as well. We did this one as well. Feel like we did this one as well. We did this one as well. Yep, we did this one as well. Okay, we completed 2026 digital logic questions. Congratulations. Yeah, and we got algorithms and we got operating systems, we got databases. Seems easy. Seems pretty easy. Should we be doing engineering mathematics? Come on. There is a person who does not know anyone else, but the person is known by everyone else. M of x comma y is equals to x plus y. There exists a person for all x such that x is not equals to y, okay? And every x knows y and y knows no x. It is not that y knows any x, right? Okay, and let's see this. For all y, x knows everyone, x knows every y, and a seems to be very apt. He wrote something here. For every person y, there exists a person x such that it is difficult. I kind of understood what that is, which is a good thing. The probability density function of a random variable with real values. Right. It is a probability density function 1 by 3 root 2 pi exponent of minus x squared by 18. X values range from minus infinity to plus infinity. Um, what to do about this question in the first place? Poisson is discrete. Eliminates Poisson immediately. Okay. You need to have a basic idea of what are different probability distributions are. Wow, how many questions are there? What? Wow, there are a lot of questions. Okay, some questions are being repeated. That's for sure. How to do this question? How to identify different distributions? Yeah, I don't know what that is in the first place, right? Probability distribution. What is the standard form of normal distribution? just if you know what normal distribution is, it works. We got binomial Poisson and f of x is equals to 1 by sigma root 2 pi e exponential minus x minus mu whole square by 2 lambda 2 sigma square. Sigma is equals to 3. Exponent is x square by 18. So x square by 2 lambda square. Okay, that honestly makes a lot of sense. It is a binary relation. Product of if the product of x and y is a square of an integer. Okay, which of the following are properties satisfied by R 1 to 10 such that belongs to R if xy is equals to I square, where I belongs to Z. You can write something like that. So if x comma y belongs to R, then y comma x belongs to R, and x comma x and y comma y belongs to R. Perfect square. So it is reflexive, it is symmetric, and it is. Let's see if it is transitive. If x comma y belongs to R, y comma z belongs to R, then x comma z belongs to R. I don't think that is the case. For example, 2 times 2 is equals to 4 and 2 times 3 is equals to wait. You need perfect squares, right? 2 times 8 is equals to 16. Nope. Alright. So what do you got? 4, 1, 4, 9, 16, 25, right? Mm, not necessarily, right? Yeah, I mean 2 8s are 16, 4 4s are 16, 2 times 8 is equals to 16, and I just could not find a good example, that's it. 4 8s are, 8 4s are, sorry, nope, nope. So 6 6 are 36. Yeah, 3 12s are, alright. Uh, nope, I cannot find a good example. But it is not valid. Antisymmetric. What does antisymmetric mean? A comma B belongs to R and B comma A belongs to R, then A is not equals to B, right? So it is can be only reflective and symmetric. Yeah. Okay. I have done this problem already. Yeah, I know that. Come on. So he's saying xy is equal to m square, perfect square, because and yz is equals to n square. Okay, and then xz is equals to question mark, right? Xy times yz. You need xz, so you need to divide by y square extra. M square times m square by y square, so mn by y whole square. Nice algebra. And what is antisymmetric? Okay. Okay, got it. 2 gamma 8 is equals to 6. Yeah, got it. We came into integration now. For a real number a, let I of a is equals to minus 1 to 1 3x square minus ax plus 1. Which one of the following statements is or are true? The value of I of a is independent of the value of a. So if you integration it, right, 3x cubed by 3 minus ax square by 2 plus from the limits of minus 1 to 1, right? So upper limit minus lower limit, 1 cube minus a by 2 plus 1 minus lower limit, that is going to be minus 1 cube is going to be minus 1 minus minus 1 whole square is 1, 1 by 2, that is a by 2 minus 1, 2 minus a by 2 minus minus 2 minus a by 2, 2 minus a by 2 and plus 2 plus a by 2 is equals to 0. So always independent of a. Okay, how did you? It is 4. It is 4, not 0. It is not 2 minus 2. It is 2 plus 2. Oh god. Okay, that works out. We have solved it. We have solved it. We got a system of linear equations: ax plus y is equals to b and 16x plus ay is equals to 24. Suppose the values of a and b are chosen such that the system of linear equations produce multiple solutions. A times b is equals to question mark. So, collinear. That means a by 16 is equals to 1 by a is equals to b by 24. That is it, right? The rank of the matrix and all of this stuff say the same thing. Actually, a square is equals to 16. A is equal to plus or minus 4. 4 6 are 24. Right, 24. Yeah, if you take minus 4 case, right, minus 1 by 4 is equal to b by 24, then b will be minus 6, then also my 24. You put it the answer somehow. Okay. And consider a complete graph Kn with vertices n greater than 4. Note that multiple spanning trees can be constructed over Kn. Each of these spanning trees is represented as a set of edges. The Jaccard coefficient between any two sets is defined as a ratio of the size of the intersection of the two sets of the size to the size of the union of the two sets. Which of the following options give the lowest possible value for the Jaccard coefficient between any two spanning trees of Kn? Wow. Ja Jaccard coefficient, it is what we are dealing with now. Consider a complete graph. So a complete graph is a graph in which like every every vertex is connected with every other vertex, something like this. Yeah, it is a complete graph. It is a K55, I think. Okay, n greater than 4. So okay, I took that subconsciously. I did not even see that multiple spanning trees. So yes, multiple spanning trees exist. For example, this is a spanning tree. This is a spanning tree, etc., etc. Okay, each spanning tree represents the Jaccard coefficient ratio of the sizes of intersection between the two sets. So the Jaccard coef is intersection to union. Okay, so let's say if you constructed a spanning tree by using 1, 2, 3, and 4, these four edges, And can you construct a spanning tree without using these? One, two, wait, one, two, here three, here four. What? Nice. So the no common edges. So zero. Is zero your answer? Yes, zero is your answer, and you have proved it easily. Wow. Wow. The determinant of a 4 by 4 matrix is 3. The value of determinant of 2A is. Determinant of 4 cross 4 is 3. Value of determinant of 2A is how much? How do you even get the answer to this? Okay. Order of matrix. Okay. Scalar multiplier. Scalar multiplication. Transformation is equals to 3. So K is equals to 2. 2A is equals to KA K power N times A. Order is equals to 4. So that is how much it transforms. 16. A. 16 times 3. 48. I see. I see. So scalar multiplication and transformation, basic things if you know the property. How to derive this? Yeah, some a part of me is saying that I can derive that. how much a matrix scales is when it flips and whether it flips orientation. A matrix transfer space. So, okay. An unbiased coin is tossed 6 times. Okay, each coin toss is independent of all previous. E2 be the event in which first, second, third, and fifth coin tosses equal heads and tails. Probability of E1 given E2 is equals to probability of E1 intersection E2 by probability of E2, conditional probability. Okay, two heads, right? So independent events, at least two, at least two heads in the sense like two heads of three or three heads of three. So you can do that expectation. Expectation. This is making sense. Two heads out of three. Uh, so if you write the sample space, 2, 3, 4, 5, 6, 7, 8. At least two heads is 1, 2, 3, 4. 4 out of 8. It is equals to 1 by 2. That is the probability of event 1 happening. And probability of event 2 happening is HHTT, right? So two heads, two tails out of 4 events. So that is 4C2 plus 4C2. 4 factorial by 2 factorial into 2 factorial. That is 12. 6 plus 6. So there are like 12 possibilities of equal number of heads out of 16. 3 by 4. I don't know. Okay. E1 intersection E2. So since they are two independent events, 1 by 2. Wow, I did it, man. I did it. This is a this is going good honestly. I like it. Consider a function. Okay, for real. My hand is paining a lot. F 0 comma 1 0 comma 1 Well, I'm happy that I'm able to solve it, and we're supposed to solve this question, right? This is a function for a real number r belonging to 0 comma 1. F of r is equals to 1 if the second digit after the decimal point in r is one of the four digits. Okay, okay. The number of points in 0 comma 1 at which f is discontinuous is. The question kind of makes sense but does not make sense at the same time. Let's look at our work. Okay, this is our work. Shall we? Yeah, honestly impressive. Mhm. That is what I have written in like how many hours again? Yeah, 2 hours I guess. No, three, no, 4 hours almost. That is what I have written in almost 3 to 4 hours. Yeah, not too bad. Let's try to understand this. The function is discontinuous if and only if the second digit after the decimal point belongs to 2357 and all succeeding digits are 0. This is because values lower than the above specified numbers by a margin smaller than 0.01 always have different values for the second digit after the decimal values. As the left and right limits are different, the same condition does not hold if the succeeding digits are not 0. Okay, what is this question trying to even answer? What is this question? Questions. Right. Yeah, function either real number is 0 to 1, output either 0 comma 1. Look at the second digit after decimal. It is 2367. Only on the second decimal digit. A function is continuous at a point, a small change in input, a small change in output, but you slightly change a number. Tiny change, output suddenly changes. Okay. So discontinuous, not example from this question that we are talking about. R belongs to 0 comma 1. F of R is equals to 1. If second decimal digit is equal to 2367. Otherwise, f of r is equals to 0. So, changes from 0 to 1 is what we consider. Example 0.019 to 0.02. Then f of r will be 0 to 1. It will stay over there until into the perturbation. Okay. My guy is using bro is using the facial English. Who's this guy? Singularity. Okay, he's sing maybe. Yeah, that's what I'm thinking. Just because there are four numbers, so um, I need to understand this table. F of y is so from 1 to 2 jump, yes, 2 to 3. Hmm. 6 to 7. 8, 9, 10. Okay. So don't that makes a lot of sense. 2026 we completed set 2 people. An iron contains one red ball and one blue ball. At each step, a ball is flipped uniformly at random from the urn, and this ball, together with another ball of the same color, is put back into the urn. The probability that there are equal number of red and blue balls after 4 step is, so it contains a red and blue ball. Okay, and let's say red is picked, then it will contains RRB. Let's say blue is picked, then it contains RBB. This is step 1. And let's say red is picked here. Here we got triple RB. But the probability of picking, let's say blue is picked here, then you will have double R double B. Let's say red is picked here, then you will have double R double B. Let's say blue is picked here, then you will have R triple B. So RB and BR case, right? Here it is 0.5 times here, like 1 out of 3, that is 0.333, or maybe 1 by 2 times 1 by 3 plus again 1 by 2 times 1 by 3, that is 1 by 6 plus 1 by 6, that is 2 by 6, that is 1 by 3. Please God, make this true. B should be your answer. See, I did not solve this question before. Yep. God, thank you. Thank you. Thank you. Thank you. I solved this question again. We are going over there, people. Yeah. There is nobody else to share my progress here, but it does not matter. We will be traveling alone. Ouch. Combinatory. Once you understand combinatorics and this thing, it will be easier. 4 by 4 matrix with element 0, comma 1. The number of such matrices with even number of ones in every row, even number of ones in every row and column. Is 0 considered even or neither even nor odd? I don't know. Okay. Think row wise first. Each row has four entries. Number of 4-bit strings with even. Okay, bro is writing essays just like me. Need some explanation for this one. Classic parity plus linear algebra discussed as combinatorics question. Parity plus linear algebra plus combinatorics. 4 by 4 matrix 0 comma 1, each row has even number of ones, each column has even number of ones. Think of mod 2 each. Okay, there is a lot of things that you are not aware of. Okay, we crossed the 2 hour mark. Let's grind for 1 more hour before going. Uh, I think we should be completing the 2026, right? Can we complete the 2026? Okay, there are a lot of questions. But you completed a set, so it really should not matter. It might take like 1 more hour, then you can jump into algorithms or something. Yeah, this is the one. So, translator, think of mod 2. Even number of ones is equals to sum is equals to 0 mod 2. What? Like double one, double zero. 1 0 but this is not 0 mod 2, right? Okay. Okay, got it. It is not binary. I went to there when he said like parity. I went to binaries. Anyways, they are good. 12:30. Right. Okay, I clearly did not understand. Throw as four entries, number of 4-bit strings with even number of ones, half of possible 16 rows, 8. Okay. The reasoning is that 4-bit row with an even number of ones. First row 1110 now has remained. Similarly, calculate the column values now. First column 101 now has the remaining element in the column must be 0 to satisfy the constraint. Okay, okay. This is another smart way of doing it actually. Like instead of doing the entire 4 by 4 matrix, he took 3 by 3 matrix as a single element. So that will be one choice, and you have three choices for rows and three choices for columns, because and one choice for the where the row and column intersect. So that is seven choices, right? Okay. To make the number of ones even, let's say in this row, 1, 0, there is no other choice, right? 1, 0, 0, 1, 0, 1. So easy. Toes of Vishnu. If it were, let's say, 0 here, then it would be 0 here as well. Then it would be 0 here as well. And it would be 1. How is it transforming? Wow. Invariant. Okay. I have learned a lot from this. For n greater than 1, the maximum multiplicity of any eigenvalue of an n-dimensional matrix with elements from R is. Multiplicity of an eigenvalue means the number of times eigenvalue is repeating. Okay. You know that I will be learning people anyways. Yeah, I guess the length of stream is enough. I will eat and after that I will get back.